Okay, first part of applications, chapter 18. So in your textbook, chapter 18 is applying calculus. And one of the first things that you need to practice understanding is how to find the equation of a straight line, which we would have done in year 9, algebra. This whole chapter is going to be focusing on tangent lines and then perpendicular lines, which we call the normal. Okay, so let's fill in a couple of information here. Tangent line is a straight line that touches a curve or a function at a single point without crossing it. So that's an example of a tangent line, right? Remember, when you find the derivative of curve at a point, it is what was it again? Every time you differentiate first principles or any derivative rule, you are finding what are you finding? Starting with G. Gradient. It's the gradient. Every time, remember, it's the first principles. It's all those 7 rules I've been asking you to do. The purpose is to find one simple idea. It's to find the gradient. It's this thing. M. Y equals mx plus c back in year 9. You can now find m with 1 point. Rather than 2 points, you've learnt the 7 different rules for 7 different functions or scenarios to find m. And what is that m? That is the steepness of the line at whichever point you're thinking of in terms of the curve. So as an example, this is a quadratic curve. Then let's say I pick a random point. I pick this point. That's a point there. If I were to draw a tangent line, it's something like that. But the steepness, that's a negative gradient. What is that gradient? You can find that with just 1 point, if you know where it is. So whatever the x coordinate is, if you know where that point is, you can find the derivative to find m. So y equals mx plus c, that line is y equals mx plus c. Okay, that line is called the tangent line. Y equals mx plus c. You can find m as long as you know 1 point. Just one coordinate. So x coordinate of that 1 point. Okay, if you know that, you can find m. That's the whole purpose. Okay, let's do an example. Let's say this is the curve. So y equals x squared. I've got y equals x squared. That's what the curve looks like. Let's say the point I chose is 3, 9. So here's 3, 9. So on your graph, that's where the point 3, 9 is. So here's my tangent line. I don't know what that equation is, but I do know it's a linear line. So it has to be y equals mx plus c. I can find m, the gradient, by simply knowing the derivative of this curve or the derivative of this function. So let's find the derivative of this function. So the function was y equals x squared. We're going to find the derivative. So delta y delta x is going to find us the gradient. Okay, so what is the derivative of x squared? Can I please have, let's go with, what I picked for a while. Let's go with Mete. 2x, very good. Which rule do we use to get 2x, Numafi? So Mete said the derivative of x squared is 2x, but what rule am I using? Power rule, very good, because it's a power function, so we use power rule. So remember the 7 rules I asked you to learn over the holidays? Power rule was one of the first ones. So we found derivative is 2x, but that doesn't tell you the gradient yet. It tells you how you can find the gradient if you know where the point is. But we do know where the point is. What is the point that I want? Where is the point that I want to know the gradient at, Anthony? 3. Because it's at 3, 9, but all I needed was just an x. So the gradient formula says, well, I can find the gradient for you. It's just 2 times whatever the x coordinate is. And I said, I want a 3, 9. So out of 3, 9, which one has the x? Well, it can't be 9. It has to be 3. So then I would say at x equals 3, because that's the point that I wanted. I wanted 0.39. I wanted to know what is the gradient of that point. Well, at x equals 3, the derivative, delta y delta x equals 2 times 3, gives you 6. And what you have to remember is that delta y delta x is m. It is the gradient of that line. So you now have found that equation, that linear equation in blue that I've got here, that line is y equals to now 6x plus c. Because I know what m is now. I know m is 6. That's what this is. When you find the derivative, that is to find m. Okay, so now that you've got y equals 6x plus c, you're back to year 9 maths again. That's the only part that's year 11. This component here. That's the only part that's year 11, chapter 18. Everything from here is year 9 maths. So let's go back to year 9 maths. You're trying to find the equation of a straight line. You got y equals 6x plus c. You don't know what c is. C is the y-intercept. How do I find c given the information I've got so far? What would you do now? What would you do now? Anyone have a clue? How do you find c? What would you have to do? Have a clue? Yeah, sub in a point. Because that's what we know. The straight line crosses through 3, 9. So if it crosses through 3, 9, it means when x is 3, the y value has to be 9. So that means this straight line, I know if it's going to pass that point, that means the y value needs to be 9 and the x value needs to be 3 because it passes through that point. Yeah? So if it passes through that point, then we know 9. So in another way, you can just say sub 3, 9. But I need you to understand, you're not just subbing it in. You have to understand it's a straight line that touches or passes through 0.39. That's why it works on it. So 6 times 3 plus c, that gives you 18. This is 9 plus c. So c must equal to 9 minus 18 minus 9. So when they say find the equation of a tangent line, well, the equation must be y equals to gradient, which is 6x, and you just found out c minus 9. So if you went to Desmos now and you typed in x squared, and you typed in the equation y equals 6x minus 9, it should intersect with that parabola exactly at 3, 9. That's the equation. Okay, so what I'm showing you today is the application to find a tangent line. But you can also find the perpendicular line using year 9 mathematics again, finding perpendicular lines. Yeah? Here we go, let's do another example. So that's the finding a tangent line, that's 18a. What's the formula to find a perpendicular line back in year 9? Anyone remember? Or even at the start of this year, that was part of your holiday for year 10, moving into year 11. Your holiday work was to revise straight line equations. What's the formula to find the perpendicular line? Let's go with Artie. Beautiful. This is one of the perpendicular properties you learnt back in year 9. If they're perpendicular, gradient of the first line times the gradient of the second line should equal to -1. Or, sometimes your teachers might have taught you, the gradient of the second line is -1 divided by the first gradient. It's up to you. You can just rearrange that equation to get that. But they're both the same. Okay? So, using the example we just did before, if I wanted to find the perpendicular line to that 0.39, you first got to find the tangent line because you get gradient 1. So M1. To find M2, you can find that out because now you've got a tangent line at 3, 9. Then you can find the normal line at 3, 9 as well. In our first example, we found the tangent line M1 equals to 6. The gradient of that line was 6. So if you wanted a perpendicular line at that same point, which is perpendicular to gradient of 6, well then based on that property, what should M2 be? What should M2 equal to? The first one, so the blue line had a gradient of 6, then what should the green line be? Green line should have a gradient of -1 and 6. Just basic logic there. -1 and 6. Yeah, because if this is, I'll do it in blue so you can see. So this blue line was y equals 6x minus 9. So that's your gradient line. Then perpendicular line, we said it's still mx plus c, But these two have to be perpendicular. So 6, that's a gradient. M1 times M2 has to equal to -1. 6 times what will give you -1? This has to be -1 on 6 for these two times to get -1. That's what this property is. Yeah? So, therefore, the equation of your normal line must be -1 on 6x plus c. And again, this is still year 9 mathematics. You just figured it out. That's the perpendicular line. How do you find c? Same job again. That line passes through 3, 9. So we say sub 3, 9 in, and you get exactly the same thing. This is all year 9 stuff, by the way. Or even at the very start of this year, your holiday work, that's what you were doing. They gave you a gradient and they said, find the perpendicular line. They gave you a gradient and said, find the parallel line. No difference. This question here, I'm not even using calculus at the moment. Yeah, the only calculus bit was just that very first bit. That's the only part that's year 11 methods. Everything else is year 9. Yeah? So here's just revising your understanding of gradients and linear equations. Right there, let's solve it. What's that? -1/6 times 3, that gives you -1/2, because 3/6 is -1/2. And then, or half, and then the negative makes it -1/2. And then adding 1/2 on both sides. So 9 plus half, you can think of it as 9.5. Or you can think of it as 19 on 2. Okay, so I just added 1/2 on both sides. You can say it's 9.5 or 19/2. Okay? And so what does that mean? The equation of the normal line must then be y is equal to -1 on 6x plus 19 on 2. If I type that in to Desmos for x squared at 3, 9, there should be a perpendicular line, which is 90 degrees, to 6x minus 9. That's 18A. That's applications. And there's beauty, or like the reason why we study calculus is that those gradients and tangent lines allows you to give you a bit of a pattern that you can see to find maximums, minimums, and that's pretty much what chapter 18 is about. Chapter 18 is about you studying how to find m, and why is m so special? Why is the tangent line so special about any curve? And really, most of it is to find the maximum or the minimum part of a curve. That's one of the reasons why. All right? Okay, team, your turn. I'm going to give you 5 minutes. Have a go with this example. So this time I gave you not a quadratic curve, I gave you a cubic curve. I even sketched out a graph for you to visualize it. I want you to find the equation of the tangent. So find the tangent line that touches this curve at the point of intersection with the y-axis. So I made it wordy. Well, what does that mean? Where's the point of intersection with the y-axis? Because you just need to know where. Yeah, you want to find a tangent line, but you need to know which point. So I've given you a sentence where the point is. Figure it out. 5 minutes. I'm going to pause the video, have a think. It's applications, it's problem solving. C. Did you get y equals -10 as the tangent line? Hands up if you got that right. Okay, good. So one of the key parts, let's dissect what we were saying here. We said find the equation of a tangent line. So I just need to know where is this curve that I'm going to type in, this straight line, where is it going to touch on the curve? So first thing I needed to know was where. So it says at the point of intersection with the y-axis. Here's the y-axis. Where does that curve, so the cubic curve, where does it intersect with the y-axis? This is right here. That's the point. But that point there, isn't that just the y-intercept? If that's the intercept, then that's when x equals 0. So if you sub 0 in, you get 0, -10. So instead of me telling you, instead of me saying, find the equation of the tangent line for this curve at 0, -10, we just change the wording and we say, find it at the point of intersection of the y-axis. It sounds confusing, but if you really read into it, that's what it means. So now you've got the point and the same thing again. The derivative tells you the gradient of your tangent line. So we just don't know what that tangent line is? At negative 10. There must be a line that crosses through or passes and touches this point, negative 10. We don't know what that straight line is. It's a y equals mx plus c line, but you can use chapter 17, derivatives, to find the gradient. So derivative was 9x squared minus 8x power rule. At which point? At x equals 0, sub it in, you get 0. Gradient 0, sub it into the equation of a line. So if m is 0, this thing cancels out, so y equals c. How do you find c? Just like before, sub in 0, negative 10, and that's how I got y equals negative 10. So if I go onto my Desmos, and we actually replicated this, you can see, let's go to Desmos, here we go. If I type in the cubic equation, y equals 3x cubed, what was it again? 3x cubed minus 4x squared, and it was minus 10. Here we go, there's my graph. And then you just found your equation was y equals negative 10. Can you see that? It literally just touches the point at 0, negative 10. It's a tangent line. Right there. It's a straight line that happens to touch at that particular point. But you can do that for any point. You can work out the gradient at any particular point. So if I want it at 1, for example, let's say at x equals 1, where is it again? So at x equals 1, let me change this to f of x just so I can do the calculation quicker. Let's say it was 2 equals 1, then find the y value at f of 1. Here we go. This is the point. 1, negative 11. If I asked you to find the tangent line, it'll be the same thing again. Whoops. Let's go back here. Let's say I asked you to find at 1, negative 11. So say this point here. That was 1, negative 11. And I'm asking find this tangent line. Same thing again. Y equals mx plus c. The only problem is you don't know what m is. What's the gradient? How do you find the gradient? Derivative. Literally, this whole chapter, this whole application, chapter 17 that I asked you to do over your holidays was to build the skill to do that, no matter which curve. We've got a power curve. It's a power function, so you have to use power rule. You found the derivative already. It was 9x squared minus 8x. So it's 9x squared minus 8x. Where do we want it? We want it at x equals 1. So here at x equals 1, derivative delta y delta x equals to 9 times 1 squared minus 8 times 1. That works out to be 9 take away 8. That means gradient is 1. So that means this line, this y equals mx plus c, now you know it is y equals 1x plus c, and same thing, back to year 9 maths. So all I did, if you really think about it, I picked a random point, y equals mx plus c, year 9 maths. Only part that's year 11 is this bit, the derivative. That is the only bit that's year 11. The rest, I just subbed it in. I said x equals 1, found the gradient, m equals 1, went back to year 9. This is year 9 maths. So that's why at year 9 level, if you remember, during subject selections, we said, is your algebra strong? Do you understand how to graph? Because that is what leads you to methods. Yeah, so that's why we got up to this bit. That's year 9 stuff. Year 9 was an important year to understand, can you work with the abstract concepts? Do you understand how to find gradients and follow a certain procedure? That's what year 9 maths is. So right here, sub in a point. I gave you 1, negative 11, and you get negative 11, 1 times 1, plus c. C must then equal to negative 12. So my equation is 1x minus 12. So if I go back to Desmos and I type it in, y equals 1x minus 12. You see that? It's a tangent line that touches that curved 1 point. And that's the whole idea of derivatives. It's to analyze the gradient of each line. So that's pretty much what Chapter 18 is going to be about. Chapter 18 is the study of what happens at every single point, what happens to the tangent line at every single point, and what's so special about it. There are two key special points. Notice when it's a maximum, gradient 0. Same thing at the minimum, the tangent line has to be 0, is going to be the next part to teach you in our next lesson. But it's really just the study of gradients. So the better you understood year 9 gradients, or at the start of this year, when I asked you to do your holiday homework, it was to understand gradients, straight line equations. Yeah? All right, team, so I'm going to finish off there. Last example, you can try yourself as well with the same thing, year 9 concept. Instead of perpendicular lines, this time it's parallel. So remember the very start of the year, chapter 1, your part of your homework's to find parallel equation of parallel lines and equations of perpendicular lines. Exactly the same thing. The only difference is there's the first step. To find the gradient, you have to use derivatives. That's it. Okay? So I'm going to stop there, and I'll give you maybe, we'll do about 15, 20 minutes, just around the 10 mark, and then I'm going to give back your sacks to have a look at, and then I'll just run through the answers on screen so that you can see. Okay? But I'll give you 15, 20 minutes just to digest the information, or I can hand it out during that time. You can have a look as well. But we'll go through the answers at 10. Okay? All right, I'll stop the